Gravity on Earth keeps everything grounded, but how do astronauts stay anchored inside satellites in space? Let's explore how gravity, or rather, an imitation of it, is produced on satellites. To begin, it's important to know that a satellite, like the International Space Station, ISS, doesn't produce its own gravity. When a satellite is orbiting the Earth, it is essentially falling towards the planet but moving fast enough horizontally that it keeps missing it. This constant falling creates a condition known as free fall, which results in what we call microgravity. Microgravity doesn't mean zero gravity, but it's so weak that astronauts inside the satellite feel weightless. Everything floats because they are in constant free fall together, so relative to each other, it's as if there's no gravity. But how do they function in these conditions? We're about to find out. Living and working in microgravity can be tricky. Basic tasks like eating, sleeping, and exercising require adjustment because of the weightless environment. But it's not just everyday tasks that are different, your body behaves differently too. Muscles and bones weaken in the absence of gravity, which is why astronauts on the ISS need to exercise every day to keep their bodies in shape. In a world without normal gravity, the human body needs special care. So, if satellites don't have their own gravity, how can we simulate the feeling of gravity? The key concept here is centrifugal force which can create a feeling of gravity through rotation. Imagine being inside a rotating space station that spins like a giant wheel. As the satellite rotates, centrifugal force pushes objects, including astronauts, toward the outer edge, creating an effect similar to gravity. This push is caused by inertia, which is the tendency of objects to resist changes in their motion. The faster the rotation, the stronger this effect becomes, creating more artificial gravity. However, the satellite would need to spin at just the right speed to mimic Earth's gravity, and the larger the satellite, the less noticeable the spinning motion would feel. This concept has long been used in science fiction, where rotating space stations or spacecraft create a believable substitute for gravity. Now, why don't we see this kind of artificial gravity on modern satellites like the ISS? One reason is that creating a large enough spinning structure would require advanced technology and enormous amounts of resources that we currently don't have. The ISS doesn't spin, so astronauts on board rely on adapting to the microgravity environment instead of creating artificial gravity. But scientists are exploring the possibility of creating artificial gravity for future space missions, especially those that involve long-duration trips, such as missions to Mars. Prolonged exposure to microgravity can take a toll on astronauts' health, leading to muscle atrophy and bone density loss. A spacecraft with a rotating section to create artificial gravity could solve some of these problems by simulating a gravitational pull similar to what we experience on Earth. Let's break down how this would work. For artificial gravity to feel natural, the satellite or spacecraft would need to spin at a specific rate. The radius of the rotating section plays a big role. A larger radius would allow the satellite to spin more slowly while still generating enough centrifugal force to imitate gravity. If the structure is too small, the required speed of rotation would be so high that astronauts could feel dizzy or disoriented. While this concept sounds futuristic, it's actually rooted in physics. You can experience a similar effect on Earth by riding a merry-go-round or spinning ride at an amusement park. The faster it spins, the more you're pushed outward, making you feel heavier, almost as if gravity is pulling you in that direction. It's the same principle at work on a rotating satellite or spacecraft. But there are challenges to creating artificial gravity. Engineers would need to design a satellite that can withstand the stresses of rotation without falling apart. The rotating structure would also need to be balanced perfectly to avoid wobbling or vibrations that could affect its stability. Additionally, the artificial gravity may not be uniform across the entire satellite. Astronauts near the center of the rotation would feel less gravity than those near the edges, creating a gradient effect. Despite the challenges, artificial gravity could be a game changer for future space exploration. In the near term, microgravity is something astronauts will continue to adapt to during their missions, but as we look ahead to long-term space travel, the idea of creating artificial gravity becomes more essential. For now, astronauts rely on innovative technologies and training to manage life in microgravity. Their food and water systems are specially designed to work in a weightless environment. They strap themselves into sleeping bags to avoid floating around while they sleep, and their exercise equipment is tailored to keep their bodies fit without the help of gravity. Astronauts also have to be careful with their movements. Even a gentle push can send them flying across the cabin since there's no resistance from gravity to slow them down. Simple tasks like brushing teeth, eating, or even drinking water are performed differently in space. Water, for instance, forms floating globules, and food must be eaten carefully to avoid it floating away. Despite these challenges, microgravity offers some exciting opportunities for scientific research. In space, researchers study how living organisms behave in a gravity-free environment. The knowledge gained from studying the effects of microgravity on the human body and other systems helps us prepare for future long-term space missions. It also provides insights into health issues here on Earth, like osteoporosis, muscle wasting, and cardiovascular problems. In conclusion, while satellites like the ISS don't produce gravity, they provide valuable insights into living and working in microgravity. The concept of creating artificial gravity through centrifugal force is being explored for future missions, but for now, astronauts have learned to adapt to their weightless environment. As we continue to push the boundaries of space exploration, the idea of artificial gravity will likely play a key role in making space travel more sustainable for humans. Who knows? One day, we may see fully rotating space stations, where astronauts walk, work, and live in conditions that mimic the gravity we take for granted on Earth. If you found this video interesting, make sure to give it a thumbs up and subscribe to our channel for more amazing content on space, science, and technology. Thanks for watching.